Welcome to Get Teched. My name's Elizabeth, and today we're gonna try not to kill any succulents. That's right, this episode is for all you plant parents out there struggling to keep your indoor plants alive. I'm gonna show you how to monitor ambient light and soil moisture levels, which are two important things to keep your plants happy and healthy. Before we get started, please like this video, subscribe to our channel, and click the bell to get notified so I can continue to bring you these lovely videos. Let's talk about plants. Right now, we're all stuck in our houses more than we'd like to be, so we're buying more and more plants to try to keep our homes cozy and colorful. But those plants require a lot of upkeep for you to keep them alive. You have to have the right amount of water and light. If you have too little, the leaves get crispy or weak. If you have too much, the leaves get yellow or bleached. Each plant has different needs. How can you know that your plant is getting exactly what it needs? I've built a project that will monitor ambient light and soil moisture so you don't have to. Here's what you'll need to build this project. I'm using two Raspberry Pi Zero WHs with SD cards and chargers, a soil moisture sensor from Adafruit, an ambient light sensor from Adafruit. I've got some connector cables, but you can also use jumper wires, and I'm using a data visualization tool. I'll be using initial state, but you can sub in any tool that you want into the code. So let me explain a little bit about the project list. Yes, I'm using two Pi Zeros. This is only because this project is to show you how to do it and how to do it easily. Could you use an I2C multiplexer to put two sensors on one Pi? That's a possibility. Could you use an ESP32 or an ESP8266 instead of a Pi? Definitely. What I'm saying is that this project is to provide you an example to get started. You can run with it, modify it, create a bigger, better solution from it. Let this project just be the foundation for you to get started. This design also doesn't make sense to replicate for every plant in your house. That would get a little expensive and excessive. So what I've done is I let this run on a plant for about 2 months. Once it's healthy and I'm confident in where it is and how much water it's getting, I move on to the next plant. Let's get the hardware connected. I'll start with the soil sensor. The sensor has 4 connections: ground, VN, SDA, and SCL. So let's connect that to our first Pi. We're gonna connect ground to pin 9. We're gonna connect VN to pin 1. We're gonna connect SDA to pin 3. And we'll connect SCL to pin 5. Ta-da! Looks like this. Now let's connect the ambient light sensor. We're gonna connect ground to pin 7. We're gonna connect VN to pin 1. We're going to connect SDA to pin 3 and SCL to pin 5. Ta-da! I'll assume that you have your Pi set up, connected to Wi-Fi, and you have a monitor and keyboard connected, or you're able to SSH into your Pi. This project runs on Python 3, so you'll need to have that installed as well. We need to test the sensors to make sure that they're connected and properly working. The first thing that we need to do is enable I2C on both devices. So, type into the terminal sudo raspi-config. Select option 5, yes to enable, and finish. You can test the connection by typing sudo i2cdetect-y1, and you should see the sensor at address 76. If not, reboot, try again, and check your connections. Before we can test the sensors, we also need to add a few libraries to get them working. The first one is going to be the Blinka library. This provides CircuitPython support in Python. Type in your terminal sudo pip3 install adafruit-blinka. The next library is for the soil sensor. Type in your terminal sudo pip3 install adafruit-circuitpython-seesaw. The third library is for the light sensor. Type in your terminal sudo pip3 install adafruit-circuitpython-bh1750. Once you have all the libraries installed, there's code in the tutorial from Adafruit that can test both the soil sensor and the light sensor. So, with your Pi connected to your soil sensor, Create a soil sensor test file by typing nano_soil_test.py. Copy and paste the code from the tutorial into the text editor, save and exit the text editor. Run the code by typing python3 soil_test.py. If it works, you'll see temperature and moisture values in the terminal. Let's do the same thing for the ambient light sensor. Create a light sensor test file by typing nano_light_test.py. Copy and paste the code from the tutorial. Save and exit the text editor. Run the code by typing in the terminal python3 light_test.py. If it works, you'll see lux values in the terminal. Now that we have both sensors working, let's move on to the data visualization piece. I'm going to be using initial state, but you can use any data visualization tool or platform that you want. All you need to do is modify the code and sub in what you're using. Initial state has plans for students that are free and individuals are $9.99 per month. All accounts come with a 14-day free trial. Once you register for your account, go to your settings and you'll find your access key here. That's what we're going to use for this project to send our data to initial state. Now we need to create Python scripts for the light sensor and the soil sensor. For your Pi that's connected to the soil sensor, create a script by typing in nano_soil_is.py. Copy and paste the code from the tutorial into the text editor. You'll see the user settings on line 7. Everything in here can be modified to your liking. Line 8 is your sensor name, line 9 is your bucket name, line 10 is your bucket key, line 11 is your access key, which you'll find in initial state under My Settings. You'll need to enter that here. Line 12 will be the minutes between the soil moisture readings. So once you make all those changes, save and exit the text editor. To run the script, type python3 soil_is.py. You can go to your initial state dashboard and you should see temperature and soil moisture data. Now we need to do the same thing for the ambient light sensor and your other Pi. So type in the terminal ambient_light_is.py. Copy and paste the code from the tutorial into the text editor. This has the same user settings starting at line 7. For this, you're gonna wanna have the same bucket ID and access key. That will allow the data to send into the same bucket that our soil moisture sensor is already sending data, which is what we want. Once you make those changes, save and exit the text editor. To run your script, type python3 ambient_light_is.py. Go to your initial state page, and in that same bucket, you should now see ambient light data. Before we get into all the dashboard stuff, let's talk about how to make sure the Pi scripts continuously run. There are 2 things that I recommend to keep your Pis working. The first is sending the IP address of both of your Pis into your dashboard. You can easily do this with our Pi process tutorial that's linked inside of the plant monitor tutorial. That way you always know the IP address of your Pis so you can easily SSH in if something goes wrong or you want to make changes. The second is to make sure that your Pi runs the script on reboot. So if the power goes out, your Pi turns off and back on, it'll run the script when it gets started. To do this, go into your terminal and type crontab-e. If it's your first time running this, it'll ask which text editor you want to use. I select Nano. At the bottom of the file, enter the following so that your script will run on reboot. At reboot, nohup python3/home/pi/plant monitor/is_soil.py %. You'll want to do the same thing for the light sensor on that Pi. So you'll need to specify the exact path and name of your file. So mine is in a folder called Plant Monitor. The nohup command stands for no hangup, and it allows your script to run in the background. All right, now it's time to make your plant dashboard. You should see your soil moisture values, These are gonna range from 200, which is very dry, to 2000, which is very wet. The temperature you see is an internal temperature sensor on your soil moisture sensor. It isn't terribly accurate, but it can give you readings to plus or minus 2 degrees, which is always good data to have. The ambient light readings are in lux, which range from 0.0001, which is a moonless, overcast night, to 65,000, which is direct sunlight. It's a pretty big swing. Let's start by changing the tiles and choose a background for your dashboard. I'll change the moisture level to a liquid gauge, the temperature to a thermometer gauge, and the ambient light to a bar gauge. I'll also add summary tiles for each of these and line graphs for each of these. For the background, I'm gonna go in and type indoor plant or house plant and see what I like. Then voila, you now have a plant dashboard. There are a few features that will take your dashboard to the next level, so I'm gonna talk about those. The first is adding outside weather data, so you can see the weather conditions and how that affects your ambient light. I can add this with no code required from the initial state integration marketplace using the WeatherStack integration. So from your home page, you should be able to click on the WeatherStack integration. Then you're gonna click Begin Setup. You're gonna name the integration. You're gonna enter your zip code, or you can enter your coordinates of your home. You wanna send the data to your existing plant monitor bucket. And then let's send some of the data instead of all of the weather information. So I'm going to send current conditions, current feels like, current UV index, and current cloud cover. I'll choose to run this every 15 minutes, and then I'll begin the integration. Now, I can go to my bucket and see this new data in there. What I'll do with the data is I'll change the tile types, rearrange a few things, map some things to emojis, and now I have a complete weather and plant dashboard. Next, I'll want to set an alert to let me know if my plant moisture level drops below a threshold so that I get a reminder to water it. I'll go to my bucket settings and then go to the Triggers tab, click Add Trigger, enter the stream name that you want to monitor. This will be houseplant moisture. I'll change the operator to less than and the value to 600. The message will be water me now when the trigger sends. I'm gonna pick where I want that alert sent to, send it to my email address, click done, and now you've got alerts so that your plant won't die. You now have a plant dashboard that will make sure you don't forget to water those succulents. If you enjoyed this video, please like it, subscribe to our channel, and share with us your plant monitor projects on Twitter. And until next time, stay hydrated, all you plant parents.